Hey, everyone. Good afternoon. I'm Takuho Mitsunaga. I'm really lucky to be here because 2 days ago, my flight, Narita to here was canceled. Then I got reassigned flight yesterday, but it was delayed. So I'm not sure I can come here, but finally I'm here. So I'm glad to see you all. Thank you. Our title is Real-Time Detection of Attack Reversing Domain Administrator Privilege. Our talk focuses on Active Directory and machine learning. We are from University of Tokyo. I'm Takuho Mitsunaga, and Wataru Matsuda, and Mariko Fujimoto. We will switch in the talk. So, as a university, we are doing research on cybersecurity or AI security, fintech security, and we are also providing cybersecurity training, not only for students, but also industrial people or government people. And we sometimes publish book or research papers, and our new books will be published next year. So this is agenda of our talk. First, we explain purpose and background as an introduction, and then we talk about previous research and the proposed method, which is combining signature-based detection and machine learning. Then we'll show you the demonstration, our method and the tools, then conclude. So as an introduction, in the targeted attack, Active Directory tend to be a target by attackers. Because if they get domain administrator account, they can control everything inside AD environment. And after they obtain administrator account, sometimes they create backdoor called golden ticket. It is not so easy to detect golden ticket abuse because they use golden ticket, they can disguise themselves as a legitimate domain administrator. So in this talk, we will explain the tools and the detection method, which is combining signature-based and machine learning detection analyzing the event log to detect attack activities, including golden ticket. So what is Active Directory? Active Directory is a centralized managed system for Windows and computers and accounts. If you use AD environment, it is so easy and effective to control machine and accounts. So many companies use the domain environment. But on the other hand, if attacker get admin account in domain, they can control everything. So AD tend to be a target for attackers. So this is an example flow of attacking AD. After attacker intrude inside the network, they try to obtain their AD environment. This is number 3. And after they can get AD account, AD admin account, they try to move different servers, like file server. This is number 4. Because after they get admin account, they can move to everywhere inside AD domain. In our presentation, we focuses on the phase 3 and the phase 4, which is attacking AD domain controllers. So golden ticket is a backdoor against the AD, which is introduced Black Hat USA 2014. If they create this golden ticket backdoor, they can use golden ticket for a long time, like 10 years. And they can pretend as legitimate admin account. So it isn't so easy to find or easy to detect the attacker's activity. This is the image of how to explain the difficulty of detecting golden ticket. The left one, the green arrow means the usual operation. By legitimate admin account, they use their account to domain controller, and the account name is DC admin. And the left one is attacker activities. After they intrude the network, they can get the compromised account like user 101. And then if they use golden ticket, they can pretend disguise account with a privilege like DC admin. And then they use their disguised account to domain controller. So in terms of domain controller monitoring, it is not easy to tell the difference between usual operation and attacker activities.
Sometimes we use built-in Windows commands in addition to attack tools. For instance, in this case, an attacker impersonates himself as a domain administrator, DC admin, and then remote access to the domain controller and execute some Windows commands such as ipconfig. And these activities are recorded in a domain controller's event logs, but if legitimate domain administrator also use the same command, so it is difficult to differentiate attackers' activities from normal operations, from event logs. So this is our proposal method. So we implemented a real-time detection tool for attack activities, leveraging domain administrator privilege, including golden ticket. And our tools use both signature-based detection and machine learning because they have advantages and disadvantages. And the signature-based detection can yield high recall rate by using several signatures. But on the other hand, a false positive can occur depending on the daily operations. Then, so our tool reanalyzes the logs by using machine learning in order to reduce the false positive rate by comparing logs with daily operations. So this is the problems of the signature-based detections. So we have a blacklist of some Windows command. But for instance, ipconfig is one of command in the blacklist. So if legitimate domain administrator use ipconfig in their operations, signature-based detection detects it is attacks because ipconfig is included in the blacklist. On the other hand, machine learning can detect it is normal because ipconfig is used in daily operations. So this is the structure of our proposal method. So when someone access to the domain controller, the activities are recorded in the event log on the domain controller. And logs are sent to a log server in real time. And at first, a log is analyzed by the signature-based detections. And then next, analyzed by the machine learning. And if any attack activities are detected, our system sends alerts to system administrator. So we use the only domain controller's event logs for input data. So activities occurred in Windows systems are recorded in event logs on each computers. But it is not realistic to investigate event logs of all computers. So the reason why we focused on the domain controller's event log is attackers tend to access the domain controller in order to create golden ticket. And there are a lot of event IDs, but we only use a specific events, so which attackers' activities with golden ticket are recorded. So we extract these following data items and used for input. At first, we explain about signature-based detection. And several existing approaches have been proposed, but we found that several approaches are needed in order to detect a sophisticated attack, such as golden ticket. So we pick up several useful existing methods and organize a specific detection signatures like this. At first, a signature ace monitors unexpected administrative privilege use. It is useful for detecting a privilege escalation activities. So there is a very famous vulnerabilities of privilege escalation. So MS-1468. So it is used in many targeted attacks. And this signature is relatively easy to detect, so it is useful for detect attack activities in early stage. And a signature base monitors the execution of the CLI tools, which attackers tend to use. So attackers sometimes use a Windows command such as net or AT, etc. So in order to expand infections or steal informations. So we register these commands in the blacklist because these commands tend to be used by attackers. But these are built-in Windows commands. So legitimate administrators also use these commands. So in these situations, false positives can occur. So that's why we utilize machine learning. So signature C monitors the use of administrative share resource. Administrative share resource is a special hidden network share resource, and attackers often use administrative share in order to put attack tools or steal information. And signature D monitors suspicious Kerberos authentication, which is suspected to a golden ticket attacks. When attackers use a golden ticket, TGT request events are not recorded before the service request. So from here, Wataru will explain about machine learning.
Yes. As she mentioned, the using blacklist leads to false positive. So we compare logs with daily operations to reduce false positive. But it's difficult to create or maintain the whitelist or blacklist manually. So our proposal method is learning the daily operations using unsupervised machine learning. Our system runs only daily operation logs. We don't need attack logs. If our system detects unusual behavior, it can be attack behavior. This slide shows overview of detection. Our proposed method runs only domain controller event logs related to process because attacker's activity is recorded as the event logs related to process. So we focus on process. Our method uses unsupervised learning to detect unusual command execution. And dataset should be the event logs only of the normal state, should not contain logs of an attack. This is premise. And we use event ID, domain controller's event logs ID 4688 and 4674. 4688 has all executed command information. On the other hand, 4674 has specific command information, but it has detailed information. So we use both event ID for dataset. We need pre-process. We discard some data commonly included in every logs regardless of environment because they are useless. They have no feature for detection. For example, LSAS and services.exe are discarded. And we convert from character to numbers using one hot encoding. And we run with one class SVM. This is an unsupervised algorithm. It optimizes decision function for novelty detection with only one level. And we've already adjusted hyperparameter to get best result. NU and gamma are hyperparameters. And we evaluate using this metric, precision and recall. So this is the result of detection rate. As you can see, machine learning reduces false positive. So only signature based, the number of false positive is 17, but combination of signature and machine learning, the false positive only 6. As a result, we achieved the precision rate has been improved. We achieved the more than 90% recall and precision rate. We implement our proposal method using Elastic Stack for real-time detection. Elastic Stack is open source product for collecting, analyzing, and visualizing event logs. And Elastic Stack realizes these items, preserve Windows event logs, and detect attack in almost real time, and send alert when attacks are detected. Specifically, we implement like this. The first, the WinLogBit. This is log transfer agent is installed in domain controller. WinLogBit sends event logs to Elastic Stack. WinLogBit receive event logs and launch the detection programs. The first, our system called signature-based detection process. And if matches signature, our system sends alert and visualize with Kibana. But in case of matching signature bit, this is suspicious command execution. Our system called machine learning process. And if machine learning process judge as suspicious activity of process, our system also send alert email for notification. This slide shows demonstration scenario. This is the premise, this is precondition of scenario. The legitimate domain administrator is DC admin. DC admin access domain controller using domain user's PC. And DC admin often use ipconfig and ping command in daily operations. But DC admin does not use AT command in daily operations. And this slide shows attacker side. Attacker have already compromised the target network and the domain administrator account, DC admin. And his computer is his computer. And golden ticket is created by attacker. And next, we will show you the demonstration movie. But our demonstration follows this scenario. First, attacker access domain controller using psexec. psexec is remote access tool using golden ticket. And attacker execute AT command on the domain controller. The signature-based detection can detect AT command successfully because it's on the blacklist. Machine learning also detects AT command because it's not used in daily operations. Finally, our system sends email to security operators. Okay. Now you are just a moment. First, now I'll show you the attacker's activity, attacker's side. So now you are watching the client PC. And account name is Gamzati. This is local user's account name. This PC is already compromised by attackers. Okay. Attacker execute Mimikatz. Mimikatz is very famous hacking tool for Windows computer. Attacker use golden ticket. Attacker inject golden ticket into the memory. No. So this is the golden ticket information. Here, the client name is DC admin. Using this golden ticket, attacker can impersonate as DC admin. And here, the expiration date is very long, almost 10 years. This is characteristic of the golden ticket. And the attacker accesses domain controller using psexec command. psexec is remote access tool. Okay, attacker access to domain controller successfully. This the result of who am I? Attacker can impersonate as DC admin successfully. In this situation, attacker's activity is recorded as DC admin's activity. And attacker can execute any command what attacker wants to do. But in this demonstration, attacker uses AT command. AT command is used for task schedule management. Attacker execute AT command for investigation. Okay, next, let's take a look at defender side security administrator display. Here, this Kibana shows Windows event logs. And you can search attack logs easily using filtering function. Now, we filter the keyword attack. Here, you can easily find out what was going on the domain controller. AT command is executed. But it's very difficult to keep watching Kibana display. So our system sends email for notification. You received email, and you received several emails. And you can see several signatures match. And this is the last email. This email tells you the executed process name and compromised IP address and account. This information is very important, very useful to respond against computer security incident quickly. Our demonstration is all. Thank you.
So these are consideration of false detections. At first, a false negative can occur if the following conditions are satisfied at the same time. At first, an attacker used the same command with legitimate administrator. And second, attacker compromised legitimate domain administrator accounts and their computers. Because in these situations, there is no difference between attacker's activities and legitimate administrator's activities in event logs. And our tool cannot detect the Windows command which are not included in the blacklist. But in these difficult situations, there is a possibility that our method can detect attack because attacker use several commands, not only single command. And we prepare several signatures. And next, false positive can occur if commands that are not frequently used in daily operations are used by attackers. So our tool needs a certain period for running normal operations. So this is the conclusions. The abuse of a domain administrator privilege means an Active Directory environment is a full control of attackers, so we need immediate actions. But detection is very difficult if a legitimate account and Windows command are abused, like a golden ticket attacks. And our method can detect attacks even if the difficult situation in timely manner. So our tool helps immediate incident response. And for future works, we are planning to analyze the event logs of client computers for further investigation. And we published our detection tools on our GitHub. Please free to use for reference. And if you have any questions, please contact this email. And we are going to introduce our detection tools in an Arsenal section tomorrow. So if you have interested in our method, so please visit our booth. So thank you for your attention.